University of KwaZulu-Natal, which consistently ranks amongst the top 5 universities in South Africa, prides itself on its academic excellence. InQubate is a division within UKZN's research office and provides campus-wide support to those research projects that have completed the research and development phase and are en route to commercialization. So UKZN InQubate is the technology transfer office of UKZN, and our mission is to develop UKZN research into solutions for society. So as such, we protect and manage the intellectual property stemming from the university and the commercialization thereof. As a public higher education institution, we are guided by the Intellectual Property Rights Act, which states that commercialization of intellectual property should be for the benefit of the South African society. So that's why we're very excited about this technology, because if it is successfully commercialized, it will benefit us twofold. One, it will protect the environment for ourselves and our future generations, but also UKZN's share of the profits can be redirected into research and development and student funding, which is a crisis that we're very much aware of. Dr. Mark Williams-Wynn is a postdoctoral fellow at UKZN, specializing in chemical process engineering.
Have you ever thought of what happens to your old light bulbs when they no longer work? At the moment, most of them are sent to landfill sites, but there's a new environmentally friendly option in crushing the light bulbs and extracting the various valuable components from the light bulbs. At the moment, the biggest problem with the crushing is the phosphor powder which is generated. So the mercury that's present in the phosphor powder is dangerous to the environment. And at the same time, there's valuable metals in the phosphor powder which is being wasted when it's sent to landfill. We have developed a patented technology which separates the rare earth metals and the mercury from the phosphor powder. This prevents the mercury from entering the environment, while at the same time extracting the valuable rare earth metals which can then be sold. We have built a pilot plant facility at UKZN, which we have used to show that the technology is able to produce market-ready rare earth metals, as well as capture the mercury from the phosphor powder and prevent it from entering the environment. This is the start of the process. The phosphor powder, which contains the mercury, is added inside, and then the vessel is sealed. We then add acids to the phosphor powder to remove the mercury and the rare earth metals. This liquid-liquid extraction column is an integral part of the separation process, where we remove the rare earth metals from the leach liquor. The process uses 2 liquid phases, which you can see here. The aqueous phase moves down as small little bubbles, whilst the organic phase goes up as a continuous phase. So now we're trying to recover the rare earth metals from the organic solvent in order to be able to reuse the solvent. So the acid comes in and the rare earth metals precipitate out from the solvent. So now we mix the acid with the solvent in order to contact the 2 phases together. And then we allow it to separate out, and we can separate the phases from each other. The end product is a rare earth metal oxide, which is of high value and it's ready for sale. So now we're looking for funding opportunities with which to construct a commercial facility that we can process the phosphor powder that's generated in South Africa and produce the valuable rare earth metals. The technology can be used to reduce the amounts of rare earth metals and mercury that are being sent to landfill site, both in South Africa and around the world. The modular nature of the technology means that it can be used to process small volumes of powder, but multiple units added together can be used to process large volumes. We would like to develop this technology to enable us to extract valuable rare earth metals from other electronic waste streams. This technology has been developed in South Africa for South Africa, but it can also be applied around the world.
If you would like to know more about these technologies, invest in them, or partner with us to ensure their commercial success, please email Mrs. Suvina Singh on singhs@ukzn.ac.za, singhs3@ukzn.ac.za, or call 031 260 4570.